Bubble sorting algorithm, expose. Sorting with no exemption, expose. Delivering nothing but the truth, this is TXCS 143, your radio dial, The Expose. Your news, our business. Broadcasting live from our home. Good afternoon, Sir JD. Good afternoon, classmate. It's Saturday, March 5, 2022. This is Jenny Samson reporting.
Serving you the hottest and the most leading news of the hour. Your news, our business.
For the background, Bubble Sort, a basic algorithm.
Bubble sort, analysis, and simulation. In time complexity, worst case, average case, and best case.
Bubble Sort, a basic algorithm. Here's Avon Algontin for the details.
Bubble sort is a basic algorithm for arranging a string of numbers or other elements in the correct order. Bubble sort, sometimes referred to as linking sort, is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. The method works by examining each set of adjacent elements in the string, from left to right, switching their positions if they are out of order. The algorithm then repeats this process until it can run through the entire string and find no two elements that need to be swapped. Each time, an element is compared with all other elements till its final place is found is called a pass. This is Avon reporting, your news, our business.
Pseudocode of Bubble Sort algorithm. Jenny Babe Samson has this report.
Here on Bubble Sort pseudocode, we declare 7 variables, and 7 is the amount of numbers in the array, so it will go from 0 to 6. We declare int I and j here because we use for loop, and we will also need a nested loop. So in here, I less than or equal to 6, it is the max value. So the part here, it is used to prompt the user to input the 7 numbers. So here, for I is equals to 0, I is less than or equal to 5, I++ is the first nested loop. The second is for j is equals to I plus 1, j is less than or equal to 6, and j++, j is equals to I plus 1, because every time this loop runs, we want j to be 1 ahead. So if I here is 3, j will start off at 4 and go up to 6. So if I here is 5, it will stop at 5 and it will go up. So 5 plus 1 is equals to 6. So now it will run once. So next is we declare a local variable, which is int temp. The temp is gonna hold the value of num_i temporarily. Then it will go back to num_j if it needs to change. So here on if statement, we have temp is equals to num_i. Here, temp doesn't have a value. You have to assign value to temp to whatever number num_i is. So num_i is equals to num_j. Say num_i is greater than num_j. So if num_i is 4 and num_j is 3, so num_i now will take the value of num_j, and num_j will take the value of temp. So instead of 4 and 3, we have now 3 and 4. So let's try to run this code. So we're gonna input 7 numbers. So now let's input So as you can see here, the numbers are sorted in ascending order, and that is for bubble sort pseudocode.
This is Jenny Samson reporting. Your news, our business.
Don't change your dial. We'll be right back with more news after the commercial.
Bubble sort's useful unless sorted partially, but very often it runs quadratically. It does sort in place and is stable in any case. And since its implementation is so short, why not sing bubble sort? Loop through each index in the list but the last one. If current is greater than next, then swap their positions. If in the loop you swapped at least once, loop again. Otherwise your list is sorted and bubble sort ends.
Hello everybody! Today I'm gonna show you a bubble sort. Bubble sort. It's a bubble sort. Bubble sort. It's a bubble sort.
Now we're back. You're still listening to DXCS 143, The Expose. Bubble sort, analysis, and simulation. Correspondent Steppy Wong reports.
I guess you already get the hang of it, so we now proceed with the analysis of the algorithm. First off, the order of an algorithm offers an upper constraint to the method's function, whereas the growth function depicts the link between the size of the problem and the value to be optimized. Therefore, the bubble sort is the most time-consuming algorithm, which has the time complexity of ordered n squared for all cases, of which is applicable to the standard bubble sort algorithm. Other ordered n squared sorting algorithms or quadratic time, such as insertion sort, are typically quicker than bubble sort and are not any more complex. As a result, bubble sort is not as useful sorting algorithm, especially if presented with a larger size of array. But it can be more efficient by utilizing a flag variable that once swapping is complete, quits the loop, thus returns now the final sorted array. Just simple as that. But since we always want to keep the rate of the growth as low as possible, we can try to make an algorithm to follow the function with least growth rate to accomplish a task. Here comes the optimized bubble sort algorithm, which following table shows the time complexity of the bubble sorts for both versions. You will know the use of optimized bubble sort to the best cases shows that ordered end is much faster than the other one. By setting an appropriate flag, we can break the cycle. In this scenario, the best case bubble sort runtime would be linear, that is, ordered n. During the first iteration of the outer loop, the inner loop executes n times without changing the flag, indicating that the data is sorted. Now observe this animated example. Say we have n array size of 8 and an iteration number of times 7, as denoted by to do. And the index shows the position of the iteration made, whether it is a comparison or a swap. Lastly, denoted by t_swap, this is with flag, a boolean function, with show if a swapping is required by setting a boolean function to look out until the array is already sorted to the end of the collections of elements. So overall, we did 6 passes. This is now the free pass, of which there is no swapping made throughout the pass, meaning that all the other elements must be at its right order. Hence, we can skip the last 2 passes of the outer loop. That would be all for the analysis and simulation.
Time complexity in bubble sort. So the time complexity in bubble sort is that it is easy to implement. Stable sorting algorithm with a time complexity of On raised to 2 in the average and worst case, and On in the best case. Bubble sort employs two loops, an inner loop and an outer loop. The two nested loops suggest that we are dealing with quadratic time, example, time complexity of n raised to 2. This will be the case if both loops iterate to a value that grows linearly with n. The inner loop deterministically conducts on comparisons, though there is an improvement in the efficiency and performance of the improved version in the average and worst case. So let's proceed to the best case. The best case for bubble sort occurs when the list is already sorted or nearly sorted. In the case where the list is already sorted, bubble sort will terminate after the first iteration, since no swap were made. Anytime that a pass is made through the list and no swap were made, it is certain that the list is already sorted. So the best case time complexity is On. When elements of the array are already sorted, then complexity includes a time loop through all elements once. Thus, it takes linear time in the best case.
Average case. Bubble sort may require n divided by 2 passes and on comparisons for each pass in the average case. As a result, the average case time complexity of bubble sort is O n divided by 2 times n.
So, worst case. In the worst case scenario, the outer loop runs ordered n times, for the collection of elements are already sorted within this loop. As a result, the worst case time complexity of bubble sort is ordered n times n and order n times n squared. Hence, that we need to get the largest growth function to estimate the number of steps an algorithm uses to solve the problem and the running time of an algorithm. So we have order n squared, for n squared is the largest element in this equation. So to sum up, bubble sort is a very simple and stable sorting algorithm to understand and implement. When the input array is almost sorted and we need to swap just a few elements, then the bubble sort is a good option. When the input array contains a large number of elements, the efficiency of bubble sort decreases dramatically and the average time increases quadratically. Though the running time of bubble sort is asymptotically equivalent to other popular sorting algorithms like insertion sort, bubble sort performs a very high number of swaps between elements.
For the recap of today's hottest news,
Bubble sort, a basic algorithm.
Bubble sort pseudocode.
bubble sort, analysis and simulation.
Time complexity. Worst case, average case, and best case.
See you again next time for bubble sort algorithm exposed. Use with no exception exposed.
This is DXCS 143, The Exposed.
Your news, our business. God bless and keep safe.